Hold on to your seats, folks, because the latest discovery in astronomy is out of this world. Scientists have just announced the discovery of a replica of our very own Milky Way galaxy, and the implications of this incredible find are truly mind-boggling. From the mysteries of dark matter to the origins of our solar system, this discovery has the potential to revolutionize our understanding of the universe as we know it. So buckle up and get ready to embark on a journey through the cosmos as we explore this groundbreaking discovery and what it means for the future of space exploration. Is the Milky Way all there is? In 1920, American astronomers Harlow Shapley and Heber Curtis met in what entered astronomy history books as the Great Debate. The two discussed the nature of the spiral nebulae and their relation to the Milky Way. Shapley believed the Milky Way was the entire universe, a massive disorganized cloud of stars, gas, and dust. He thought the spiral nebulae were minor subgalaxies inside this super-universe. Curtis thought the spiral nebulae were separate galaxies and island universes, and the Milky Way was only one of them. 4 years later, the fellow American astronomer Edwin Hubble found the truth. Using a different method that extended the reach of parallax, he managed to determine that the Andromeda Nebula was at least 1 million light-years away from Earth, way too far to be part of the Milky Way. At that time, astronomers finally realized that the Milky Way was just one of many galaxies. Dutch astronomer Jan Oort, sometimes dubbed the master of the galactic system, made further leaps in our understanding of the galaxy. In the 1920s, he used proper motions of stars to prove that the Milky Way isn't motionless but rotates, and calculated the speeds at which stars at various distances orbit around the galactic center. His work also led to the discovery of Earth's position in the galaxy, the space breakthrough. Over the following decades, astronomers, aided by the improvements in telescope technology, started finally piecing together a crude three-dimensional picture of the spiral-shaped Milky Way. The advancements went hand in hand with the expansion of the catalogs of stars, their parallaxes, and proper motions. In 1924, American astronomer Frank Schlesinger published a catalog with the parallaxes of almost 2,000 stars, probing stellar distances out to a few dozen light-years from Earth. His catalog was extended to about 6,000 stars by Louise Freeland Jenkins in 1952, and to over 8,000 stars by William Van Altena in 1995. But the flickering effect caused by Earth's atmosphere and the distortion of the telescopes caused by Earth's gravity prevented astronomers from reaching a precision better than about 0.01 arcseconds. Today, with advanced technologies such as adaptive optics and interferometry, we can reach accuracies of a few dozen micro-arcsecond on large ground-based telescopes, says Joes. These data, however, always refer to individual objects or very small number of stars. These telescopes today use data from Gaia to calibrate their outputs. The same galaxy, NGC 3949, also known as UGC 6869, is an unbarred spiral galaxy of about 30,000 light-years across, located about 50 million light-years away in the constellation of Ursa Major, while it is moving away from us at approximately 800 kilometers per second. It is a member of the M109 group, a loose cluster of over 70 galaxies located in the constellation Ursa Major. It is one of the larger galaxies of this group. NGC 3949 is probably very similar to the Milky Way in terms of shape and structure. Like our Milky Way, this galaxy has a blue disk of young stars peppered with bright pink star-forming regions. Stars in the disk whirl around the bright central bulge, which is, in contrast to the blue disk, made up of mostly older, redder stars. The Type I supernova SN 2000 Dibit is the only supernova that has been observed within NGC 3949. A Type II supernova results from the rapid collapse and explosion of a massive star. A star must have at least 8 times, and no more than 40 to 50 times the mass of the Sun for this type of explosion. It is distinguished from other types of supernovas by the presence of hydrogen in its spectrum. Type I supernova are mainly observed in the spiral arms of galaxies and HI regions, but not in elliptical galaxies. This image was created from Hubble data taken with the Wide Field Planetary Camera 2 in October 2001. Separate exposures through blue, visible, and near-infrared filters have been combined to make the natural location. The NGC 3949's location is 1153.41.731.104.1896 RA, and plus 475131.40145146 December. They are celestial equivalents of longitude and latitude. The right ascension, longitude, is the angular distance of an object along the celestial equator from the March equinox. As a rough guide, the March equinox is located in the constellation of Pisces. If the number is negative, it is west of the March equinox. The declination, latitude, is the galaxy's angle from the celestial equator. A negative value indicates it is in the southern hemisphere. Based on the location of Ursa Major, NGC 3949 can be located in the northern hemisphere of the celestial sky. The celestial hemisphere is equivalent to the hemispheres on Earth. NGC 3949 is north of the ecliptic. The ecliptic is the path the Earth takes as it orbits the Sun. As the Earth is titled, we have celestial and ecliptic hemispheres. Attributes of NGC 3949. Radial velocity. Radial velocity is the speed at which an object moves away / towards the Sun. For NGC 3949, the radial velocity is 0798.00 kilometers /s. When the value is negative, the deep space object and the Sun are getting closer. Likewise, a positive number means that the two things are moving away. NGC 3949 diameter. Calculated. The diameter of NGC 3949 is an estimation. It is based on a calculation rather than a pure written paper. The formula that I am using is from a Stack Exchange answer. I am assuming 3,261,633.44 light years to a megaparsec. The diameter of NGC 3949 is 26,550.75 light years. To put this in context, the Milky Way galaxy, which is the galaxy that we currently reside in, is about 100,000 light years across. The NGC 3949 is therefore small than our home galaxy. NGC 3949 distance to Earth. NGC 3949 distance to Earth is an approximation as we don't know the exact distance. It is based on calculations and observations. The currently recognized distance at the time of writing is roughly 54,885,595.24 light years. As we know the distance, we can calculate how long it will take to get to NGC 3949. How long does it take to travel to NGC 3949? The time it takes to travel to NGC 3949 depends on how fast you are going. UG has done some calculations as to how long it will take to go at differing speeds. A note about the calculations: when I'm talking about years, I'm talking about non-leap years only. 365 days. The New Horizons space probe is the fastest probe that we've sent into space at the time of writing. Its primary mission was to visit Pluto, which at the time of launch, 2006, Pluto was still a planet. In conclusion, the discovery or replica of the Milky Way is a testament to the incredible advances we have made in astronomical research. This incredible feat not only expands our understanding of our galaxy, but also opens the door to exciting new avenues of exploration in the universe. As we continue to uncover more mysteries of the cosmos, we can only imagine the incredible breakthroughs and revelations that await us in the future. So let us continue to push the boundaries of scientific discovery, and who knows what other remarkable discoveries lie ahead. If you found this video informative, make sure to hit the like button, share it with your friends and family, and subscribe to our channel for more exciting content like this.